So we are given a pair of equations here, x plus y is equal to 5 and 2x plus y is equal to 7, and we have to solve them using the graphical method. So the graphical method is the third method of solving simultaneous equations, in which you're going to be graphing the equations and the intersection point between the two equations will be your solutions. So let's label this equation 1 and this will be equation 2. So to make an equation into the graphical form, we start by making y the subject of the equation. So for equation 1, x plus y is equal to 5. If we make y the subject, we'll be moving x to the other side. Therefore y is equal to 5 minus x. Now for equation 2, 2x plus y is equal to 7. Again, we have to move the x to the other side to make y the subject of the equation. So y is equal to 7 minus 2x. So now we've made y the subject of these equations, and we'll be able to get points in which we can use to plot the graphs. So this, what we have, is an equation of a straight line that can be plotted in the graph. So for the first part, for equation number 1, we start by taking points which we can use to plot on the graph. So let's assume that the value of x is 1. So if x is 1, then y is gonna be equal to 5 minus 1 if x is 1. So that is equal to 4. Therefore, one of the points will be 1, 4. So for equation 2, again, if I substitute x as maybe 2 in this, then y is going to be equal to 7 minus 2 times 2, because x is equal to 2. So that's 7 minus 4, which is equal to 3. Therefore the another point in this equation could be 2, 3. So now once we know that we can find the points of the equations with this method, we can maybe have a table of values so that we know exactly what points will go on the grid and plot the graphs. So I'll draw a table of values from x is equal to 0 all the way to 6. So this is my table of values of x. So that's when x is equal to 0, 1, 2, 3, 4, 5, 6. Now for y, I will have it as y1 and y2. So this means that this y value will be for equation 1 and this y value will be for equation 2. So now let's start substituting x and getting our answers. So let's start with x as 0. When x is 0, in equation number 1, which is x plus y is equal to 5, so y is equal to 5 minus x. So when x is equal to 0, it's going to be 5 minus 0, which is just 5. y2 is equal to 7 minus 2x, and we know that, and we are substituting x as 0 into this equation. So 7 minus 2 times 0, so 2 times 0 is 0, therefore it's going to be 7 minus 0. So y2, the y value when x is equal to 0 for the second equation will be 7. Now we'll complete the table until the value of 6. So let's complete it for y1. So when x is equal to 1, with this equation we know that y is equal to 5 minus 1, which is equal to 4. When x is equal to 2, it's going to be 5 minus 2, which is 3. When x is 3, 2. I hope you're seeing a pattern: 5, 4, 3, 2, 1, 0, minus 1. There becomes a linear pattern here. Now for the second equation, y2, when x is equal to 0, we got that y is equal to 7. And now when x is equal to 1, it's going to be 7 minus 2, which is equal to 5. When x is equal to 2, it's going to be 7 minus 4, which is equal to 3. When x is equal to 3, it's going to be 7 minus 2 times 3, which is 7 minus 6. So y is equal to 1. Again, we can see a pattern: 7, 5, 3, 1. These are all decreasing by 2. So rather than substituting and getting your answer, you could just continue the pattern so that it saves time. So minus 1, minus 3, minus 5. So these are all your values, the table of values. So now we know exactly what points to plot on the graph, and the intersection point will be the solution to the equation. So now we have the grid, the table of values, and the graph. So in this graph, every distance of 2 boxes represent 1 unit. So 1, 2, 3, 4. That's how I've drawn the graph. So now let's start plotting the graph. When x is 0, y1 is equal to 5. So when x is 0, y1 is equal to 5. Therefore we have this point here. When x is equal to 1, y1 is equal to 4. So 1 is here and 4. Therefore we have another point. Again, when x is equal to 2, y1 is equal to 3. So we have our third point. Again, we can see that it's becoming a straight line. So these all follow. When x is 3, y is 2. When x is 4, y is 1. When x is 5, y is 0. And when x is 6, y is minus 1. So we've got these sets of points which we will be using to plot the graph. Okay, so plotting these points, now I'll draw the line. So this becomes the line for equation 1. So I'll label this as 1. Now since we've got the graph for equation 1, we can move on to get the graph for equation 2. So now we do the same thing with equation 2. When x is 0, y is 7. So we have that point. When x is 1, y is 5. So we have that point. When x is 2, y is 3. Again we have that point. When x is 3, y is 1. So we have our fourth point. When x is 4, y is minus 1. Again, there's a pattern which we can see. So when x is 5, y is going to be negative 3. Every y value is decreasing by 2 as an increase of x value by 1.
So once I join the points of equation 2 with a line, this is how it looks like as shown by the blue line. The intersection point of the two lines will be my solution to the simultaneous equation, as the x value and the y value at that specific point is same for both the equations. Therefore my intersection point, which in this case is 2, 3, will be the answer or will be the solution to the equation. The intersection point is highlighted by the blue marker, which in this case is 2, 3. Therefore 2, 3, or when x is 2, y is 3, becomes the answer to the simultaneous equation solutions. Another way to validate our solutions is by looking at the table of values. We see that when x is 2, y is 3 for equation 1 as well as equation 2. Therefore, for one x value, which is 2, y is 3 for both the equations. Both equations have y as 3 as their values when x is 2. Therefore, making x as 2 and y as 3 as a solution to the simultaneous equation.